In the first video we learned that an image is a template for the environment that you want to run, and when you run an image you get a container. We tried this out by running a PHP image. This was okay for our very simple application, but imagine if you have something more complicated. Let's work through an example. Traditionally, a big website, like an online store, would be one big application, but a newer trend is to split these big applications up into smaller microservices. The website can then be quite minimal, and it just makes calls to other services to get information or to ask them to do some piece of work. We're going to build a really simple e-commerce website, but we're going to put the code that provides the products and the product information in its own microservice. The website will then use an API on the product service to request the list of products to show to the customer. Something I touched on at the end of the last video is how you should only have one process per container, so each container should provide a single service. For this we'll want one container running the website and one container running the product service. This should be independent. This means that they can be written in different languages, but they do need to be able to talk to each other, but we'll get to that bit later. Let's start with the product service. I'm going to build this using Python. I'm going to create a new directory for this service called product. And in here I'm going to write a very simple Python script. I'll call it api.py. Remember, this is not a Python tutorial, so this is just going to be a very quick example. So this is going to be the product service. I want this to be a simple RESTful API, so I'm going to import Flask and Flask RESTful and instantiate these objects. Then I'm going to have a product class which extends resource, and this is just going to have a get method which will return some JSON. So we want to sell some ice cream, some chocolate, and we'll be healthy and sell some fruit as well. I'm going to add the routine at the bottom, and then finally just some code to run the application. Listening on port 80 with debug turned on. Obviously a real API would return a lot more data than this. It would be a lot more thought out and a lot better in general, but this will do. Since I've used Flask and Flask RESTful, I'm going to add these to a requirements.txt file. So this is a list of dependencies. Pip can then use this file to install everything. This is not specific to Docker, this is just a Python thing. But now let's get this running in a Docker container. First I'm going to make a Docker file. Remembering back to the previous video, the first line needs to use the from keyword to specify a base image that we'll then build on top of. There is an official Python image that we can use, we just want the latest version of Python, and you'll notice it has these onBuild tags. It explains further down the page that these ones automatically install requirements from the requirements.txt file. This sounds very useful for us. It's as if I planned it in advance. So let's put this in our Docker file from Python : then the tag 3 onBuild. Next we want to copy the source code into the image. So we just want to copy the current directory into /user/source/app. I've chosen user/source/app because this is what the onBuild image expects. Then we need to give this a command to run when it starts. I'm using the command keyword and then this weird array-like syntax. We can tell it to run Python, and any subsequent elements in this array are arguments passed to Python. So we can just tell it to run the script api.py. So we already know how to run this using Docker. We do docker build to create an image out of the steps defined in the Docker file, and then we do docker run and add some various arguments to specify ports and mount volumes. But you might find this gets a bit tedious, and as we add more containers, running more of our services, building and starting each one separately, and making sure they can communicate is just a pain. This is where Docker Compose comes in. Docker Compose lets us define all of our services in a configuration file, and with one command it'll spin up all of the containers that we need. The first thing we want to do is make a file called Docker Compose, and I'm going to do this one directory up because this is going to cover all of our services. So it wants to be called docker-compose, and it's a YAML file, so the extension is YML. In this file we start by specifying the version of the compose file format. We do version : and we're going to go with 3. Docker has changed a lot in the last few years, and they keep changing the way compose files have to be written. So this doesn't relate directly to the version of Docker Compose that you have installed. This is just the version of the Docker Compose file format that you wish to write in. The latest version right now is 3. There are subtle differences between each version. There's no reason not to use the latest one. After this, we specify our services, so we write services : and we'll start with product service. So we give it a name, it can be anything you want. First, we tell Docker Compose what to build, so we use the build property, and we give it a directory containing the Docker Compose file. So the folder is called product. We can see here that we've got the folder called product next to Docker Compose.yml. The directories are relative to where the Docker Compose file is. Next, we can specify volumes, and this is done as a list. So you can have as many as you want. The format is a hyphen, then a space, and then the directory on the host, so your computer, so product, and we want to mount that in /user/source/app. So of course the image when it's built will already have the code inside, but mounting a volume makes development easier because it'll see live code changes as they happen. We can do the same with ports. To another list, our application is listening on port 80, so we want to map something to port 80, so to the port on the host we'll use 5001. This can be anything. You could map it to port 80, but it might clash with a web server already installed on your operating system or something else using port 80. Easier just to avoid it, we'll go for 5001 and connect that to port 80 in the container. And that's all we need. This is the stuff that we would have previously specified in the docker run command, but in a much easier format and saved in a configuration file. To run this, we go back to the terminal and type docker-compose up. Now you obviously want Docker to be running already. I'm assuming you have Docker for Mac or Docker for Windows installed and that app is already open. And as long as we're in the same directory as the Docker Compose file, it'll automatically start the services, it'll build the images if necessary. In this case it's going to download that Python image we found on the Docker Hub. The onBuild trigger will run here automatically and install our Flask dependencies. And then finally it'll run our container. So if we go to a web browser, we can go to localhost 5001 and it works. It gives us our JSON array of products. If we make a change to the product service, let's say we also sold eggs, because we've got the volume mounted, Python sees the change, it detects this and reloads. So now when we refresh we get eggs as well. Okay, we can press Ctrl+C in the terminal to stop that container. Now we want to build the website which will use this product service. So make a new folder called website. I'm going to write this in PHP. Again, it's going to be very quick and simple. We'll make a file called index.php. We'll add a little bit of HTML. What I want to achieve here is a bullet point list where each element in the list is a product from the product service. So let's open PHP tags, and I can use this function called file get contents. I wouldn't recommend this in production, but it works for an example. This function, you give it a URL and it returns a string containing the contents of whatever is at that URL. Now we get to the interesting question of which URL to use. When we access the product service locally, we can use localhost 5001. This won't work within a Docker container because for the container, localhost will be itself. Conveniently for us, Docker Compose creates a virtual network for all of the containers. So by default, each container can access all of the others defined in the compose file. And their host names match the service name, which is nice. So we called it product-service. This is the host name that we can use in our PHP script. So we can do http://product service. And when we use Docker Compose to run this, that will resolve to the product service container. So $JSON will contain that raw JSON straight from the product service. We can decode it, then we can pull the products out of it and loop through them and echo each one in a bullet points list item. For this we could write a Docker file again, but instead I'm going to demonstrate another way to use Docker Compose. We're going to make a new service called website, and instead of specifying a directory to build with a Docker file inside, we can just use the image property and give it a name of an image. So this could be an image we've built previously ourselves, or it can be an image straight from the Docker Hub. From the previous tutorial, we know that there's a PHP image that we can use, and we want the version that comes with Apache. Next, we want volumes. So with the product service, this was just for convenience because we made a custom image which included the source code. This time we're getting the image straight from the Docker Hub, so it's not going to include our source code, so we need the volume here for anything to happen. So here we want the website folder to go in /var/www/html. Again, this is just dependent on the image that you use. PHP expects it to exist in that directory. Again, we can do ports, port 5000, to map to port 80. And finally, we can use the depends on property. So we know that the website's not going to work unless the product service is running. That call to file get contents would just fail. So we can tell Docker Compose that the website depends on the product service. So it just uses this name here. You can list multiple things that a service depends on. So now when we do Docker Compose up, it's going to pull that PHP image, then it'll start the product service, then it will start the website. So when we go to localhost 5000, it doesn't work. What's gone wrong? We need to pluralize products. Now when we refresh, welcome to my shop, then the PHP script made a call to the product service, decoded the JSON, and it displays it on the page. And we can see how easy it is to start all of these services and have them communicate. It's all defined in this config file, which is easy to change and saved alongside the code, so you could commit this to GitHub, for example. Then anyone else who works on the project just has to run Docker Compose up, and everything will happen automatically. They don't have to go to any effort to configure a dev environment. Another feature of Docker Compose is detached mode. You can do Docker Compose up -d, and this will run it in the background. So I can continue to do work. We can type docker ps to see that those containers are running. So we've got the PHP one and the product service one running there. This also shows us that the PHP image is unmodified straight from the Docker Hub, whereas the product service is using our custom image, which it is named tutorial_product service. You obviously can't do Control-C anymore to stop them, but you can do Docker Compose stop. I hope you see the power of Docker Compose, and I hope that this helps you out when running Docker containers. If you've got any questions or feedback, please do leave a comment. If this was useful, I'd really appreciate a like, and if you want to see more of this, then do subscribe. In a future video, we'll look at Docker deployment options. Thanks for watching.